Good morning, sir. This is a review one for real-time face mask detection for CSE 2506. And our group members are Hemateja, 19BSc 1025, and Joshan Sai, 19BSc 1031, and Ishwar Gautam, 19BSc 1135. So, today the introduction is going to be explained by Ishwar Gautam.
As we know, due to COVID outbreak, social distancing is a mandatory task. So persons having COVID-19 can expose anyone who is in close contact with them to infective beds. Surroundings of an infected individual can cause contact transmission as droplets carrying virus may arrive on the edges and surfaces. So due to this, wearing face mask is a mandatory precaution in any public places. Now, next challenge is to make sure everyone is wearing the mask or not. So for this to occur, face mask detection will help a lot, as we'll be detecting whether the person is wearing a mask using deep learning and machine learning techniques. So this is the literature survey we have done. So the first paper we have seen is COVID-19 face mask detection using TensorFlow, Keras, and OpenCV. So in this paper deals with well-known deep learning techniques called CNN. This paper implemented a series of convolution and flattened the network to get the final binary output as one. Yes, 1 for yes and 0 for no. So this paper achieved 93% validation accuracy. So the next paper we have referred is retina face mask. A single stage face mask detector for assisting control for COVID-19 pandemic. So this paper deals with ResNet model architecture. In this paper, they use the ResNet layers such that more information will be passed to future layers without involving any challenge. And this paper achieved 68.3 MAP. Detection of face mask using convolution neural network. This is the third paper we have referred. So this paper deals with the conventional feed-forward neural networks with convolutional neural networks. They have added a feed-forward neural network in between convolutional layers. This paper achieved 92% validation accuracy. From here, Hemitesh will continue.
Yes, sir. So the objectives of this project are just to, first of all, gather the dataset that we need using two major tools, the OpenCV and label for labeling the tasks, and then pre-process the dataset using using other OpenCV models for OpenCV tools. So we have to make all the dimensions same and have they should be having different brightnesses so that our model could be more robust to new images. And then we need to analyze the dataset to divide it into two classes, 0 and 1. 0 representing there is no mask in the photo or the person is not wearing any mask. 1 representing the person is wearing a mask with equal number of images. So because we need to avoid the bias into the model, so we need to have equal number of images for both classes. And then we need to split the dataset into training and testing datasets with around 80% to 20% split. And then training the models on the training dataset, testing dataset would be the next challenge to do. And after completing the training, we need to compare the results of and we need to infer the performance of the models based on the ML and DL techniques. So this project is basically a binary classification problem, like whether a person is wearing a mask or not is just a binary classification problem. So we have several machine learning techniques that classify the images, and we also have a very few good deep learning models, so which outperform in a critical situations like the luminance of the image is high. So the machine learning techniques that we are going to use are support vector machine, the SVM model, and then the k-nearest neighbors. So after that, we will be using the deep learning techniques called YOLO V4 and SSD MobileNet. So the YOLO V4 and MobileNet are detection models, not in the sense of classification models. Those two are detection models. They can also detect whether where is the bounding box of that particular mask is where. So the work done till now is we have completed the literature survey for the papers that we have already shown, and 50% of the dataset has already been collected, and we'll be augmenting it to make it a double size or 100% of the dataset. So we completed this setting up for training ML and DL models in our workbench. So the work planned is pre-processing the data set. So the first thing we need to do is pre-process the data set, and then we will be doing machine learning and deep learning separately. As we already said, the machine learning we will be only doing two models, like support vector machine and KNN, and under the deep learning category, we will be doing YOLO V4 and SSD mobile name. So this is the Gantt chart, sir. And the review one, we have completed the literature survey, dataset collection, and environment setup. But before the review two, we will be completing pre-processing the dataset and augmenting. And after that, we will be training the deep learning models like the YOLO V4 and SSD mobile net. And after that, we will be analyzing the performance of those deep learning models. In the before review three, we will be completing all the ML model training and also completing the performance analysis. And before the report submission, we will be we'll be comparing the both ML models and DL models together, and we'll be inferring on the performance and what are the reasons for that type of performance for this particular data set. And we will be preparing a detailed report of the work by tabulating the results and by visualizing the results at the report submission time. Thank you, sir.